I'm making an everyday carry folding knife. It is the most ambitious project I've ever attempted. Featuring a 154 cm blade steel, aluminum liners, micarta scales, and a titanium liner lock and clip, it is truly a work of art. I modeled the knife after the Vero Synapse Mini, a beautiful knife that I can't afford. The build begins with a paper template taken from the CAD model. I glued it onto a 1/4 inch thick aluminum bar using hot glue. One trick here is to preheat the metal so the glue sticks better. Next, I roughly cut the shape using a hacksaw. I then used a carbide burr on a Dremel tool to refine the shape. Finally, I ground it the rest of the way on my belt grinder. I used a center punch to mark the holes before I drilled them. I used a drill to transfer the holes to the other side of the handle. I glued the two handles together so I could grind them to match each other. I filed out a part for the flipper tab. Next, I used the drill press to widen the holes to their final diameter and tapped them. These holes will have a M3 thread, which means they are very small. This block of aluminum will later become a jig to hold the scales in a mill. I'm using Sharpie as layout fluid and a drill bit as a scribe. Drilling aluminum with a sharp drill bit is so satisfying. It just never gets old. Breaking taps is definitely one of the most frustrating parts of machining. Luckily I had a second M3 tap laying around so I could continue the build. Seeing that I do not own a mill, I was kindly allowed to mill my parts at my high school with their knee mills. I'm milling a pocket in the aluminum, where the micarta scales will later go. Since the micarta scales I ordered were too thick, I'm thankful for my neighbor Greg who helped me plane them down thinner. I spent a long time sanding and filing the part where the micarta meets the aluminum, so there's a seamless transition. Next, I center punched, drilled, and tapped the holes in the scales. I then used my scroll saw to cut out the scales and the disc sander to refine them. Next, I countersunk all the holes in the handles so that the screws will sit flush. Since the handles will have a chamfer on them to make them more ergonomic, I used the disc sander to create that. One tip that I am doing here is using an air compressor to spray air at the part to cool it down. This cools quite effectively without having to use water. Next, I sanded the handles from 120 grit all the way to 2000 grit. This gives them a nice mirror polish. I used finishing wax to finish them. This helps fill the pores of the micarta. Then I used a buffing wheel to buff it out. Next, I'll use my sandblaster to sandblast the aluminum handles. Next, I sand them with 2000 grit sandpaper to take the edge off of them. And just like that, the handles are complete. Now I'll begin on the knife blade. This is a piece of 154 cm steel I ordered from usa-knifemakers.com. Here I'm using the blowtorch to heat it up and then a hot glue stick rubbing on it to get glue on it. This worked extremely well and I recommend it for gluing templates onto metal. Next, I cut off the blade using an angle grinder. I used my belt grinder to finish shaping the blade. Seeing that I've never worked with stainless steel for knife making before, I was very worried that it would be hard to drill and grind. Luckily, I was pleasantly surprised when it was very easy. I then used the Dremel to grind in the sharpening choil. This will make it easier to sharpen once the knife is finished. Next, I am machining a curved slot that will stop the blade at its fully open and fully closed position. First, I'm using calipers to mark it. I'll be making the slot by drilling a bunch of tiny holes, so first I use a center punch to mark where they'll be. And there is the finished slot. It's not perfect, but it'll work. This is how the slot will function inside of the finished knife. Next, I scribed a rectangle that will become a nail knife. I milled it at school as well. Next, I drilled the pivot hole to its final size. However, because my drill bits are not sharp, it took many attempts. To prepare for grinding the bevels, I marked the center of the blade using a drill bit that was the same width. I also used calipers to describe how high the bevel should go on the knife. This is a jig I made out of angle iron to hold the knife at an angle so I get consistent bevels. Next, I shipped the knife to Texas Knife Maker Supply to get heat treated. Now we'll be making the backspacer out of aluminum. I started by tracing the rough pattern of the back of the handle to the piece of aluminum. I then glued the backspacer onto the handle so that I could trace the contours of the blade onto it. I also drilled a second hole through the handle and backspacer so that it didn't rotate. Since the backspacer was being held in the handle, I took the opportunity to grind it flush. Next, I decided to solder the backspacer on and not use the second hole. Then I began making the pivot screw out of a piece of 1/2-inch stainless steel round bar. I countersunk the aluminum so that the pivot screw would sit flush. Then I test fit the whole assembly. The washers are made of phosphor bronze and will lubricate the action of the blade. Now to make the stop pin that keeps the blade open or closed. I tried to cut it using tin snips and this worked okay, but I later found that using a cut-off disc on the Dremel worked a lot better. Using the blowtorch, I heated it up and peened the end with a hammer. This will ensure it doesn't fall out of the handle. Then I soldered it in place. After being ground on the belt grinder, it nearly disappears. Next, I'll be making a pocket clip out of this sheet of 2mm thick titanium. I heated it up and used a small ball-peen hammer to give it some texture. I was also surprised by how easy it was to drill the titanium. I originally blowtorched the titanium to show its temper colors, but later decided to sandblast it. Next I'll be making the liner that also includes the lock, that's why it's a liner lock, but the titanium was too thick, so I milled it thinner. Thank you to Mr. Buzzpoon for letting me use his mill. This is a cool technique I found where you utilize climb milling to thin out a piece of sheet metal. One of the difficult things about grinding titanium is that it's very gummy, and it likes to form clumps rather than just becoming dust. Here's the finished handle with the titanium liner inside. After about a week of waiting, I received my blade back in the mail. There's some really cool temper colors on it, with purple, blue, and orange hues. However beautiful the temper colors were, I needed to remove them, so sandblasting was a great option. This provides a nice, smooth, matte finish. Next I'll be making the locking mechanism, so I marked where the blade interacted with the liner using a Sharpie. cutoff wheel on the Dremel to cut out the lock. This was very nerve-wracking because if I messed up, I'd have to remake the whole liner. Luckily, it worked out okay. Next, I used some sandpaper to take off the burrs created by the cutoff wheel. In order to make it lock, I had to bend the titanium to the side, and I used pliers for this. Then there was a whole lot of filing and adjusting in order to get it to lock up just right with the blade. Most of this I did off camera though. Next I had to install the detent ball. This is a 1/16 inch ball bearing that ensures the knife won't accidentally open when in closed position. I drilled out the hole and then press fit the ball into it. Next, I assembled the knife and used the ball as a scribe to scribe a line to show me where to drill a hole in the knife blade. I quickly discovered that hardened 154 cm stainless steel is nearly impossible to drill into, so I had to grind it out using a Dremel. Then I was on to sharpening. To fit the pivot bearings, I had to drill a recess on either side of them. I used a Forstner bit for this. It's generally intended for wood, but it worked okay on the titanium and aluminum. And now, after nearly a month and a half of work, the knife is finally finished.